At the equator, you are moving east right now at 465.1 meters per second. That is about 1,674 kilometers per hour, faster than the local speed of sound. You do not feel it because the ground, the atmosphere, the oceans, and you all share almost the same motion. But imagine that the solid Earth stops in a single instant while everything not locked to it keeps moving. The first catastrophe is not a year-long day. It is inertia. This is an impossible thought experiment, so the assumption matters. We are stopping the solid surface relative to space, but allowing air, water, and unsecured objects to keep their momentum at first. No known force could do this cleanly. Earth's rotation stores roughly 2 times 10 to the 29 joules of kinetic energy. Any real mechanism able to remove that motion instantly would be a planetary disaster by itself. The fictional stop lets us isolate what rotation is doing for us. Speed depends on latitude. The equator travels the largest circle in one day, so it moves fastest. At 40 degrees latitude, the eastward speed is still about 356 meters per second, or roughly 1,280 kilometers per hour. It falls towards zero only at the geographic poles. When the ground stops, a person, vehicle, or loose object does not automatically lose that sideways velocity. Near the equator, the relative motion begins at more than Mach 1. The atmosphere behaves the same way. Air does not know that the ground has stopped, so it initially continues east. Calling this a 1,674 km per hour wind is only a first approximation. Terrain, friction, pressure waves, and collisions would rapidly make the flow far more complicated. The oceans also retain their momentum. Water would surge across basins and coastlines, but there is no single honest global wave height. Any exact number would require a coupled model of topography, atmosphere, ocean depth, and the unspecified stopping force. The familiar weather system would then begin to reorganize. Today, Earth's rotation creates the Coriolis effect, deflecting large-scale motion to the right in the northern hemisphere and to the left in the southern hemisphere. It helped shape jet streams, trade winds, ocean currents, and rotating storms. NOAA explains that without rotation, the long-term atmosphere would tend toward a simpler circulation between the warm equator and cold poles. The immediate winds would be violent, the eventual global circulation would be less twisted. One effect is surprisingly small. You would weigh slightly more at the equator. Rotation currently produces a centrifugal acceleration of about 0.0339 meters per second squared there. That reduces effective gravity by only 0.346%. Remove it and an 80 kilogram person scale reading changes by the equivalent of roughly 0.28 kilograms. The catastrophe comes from momentum and climate, not from gravity suddenly crushing people. Earth's shape would also begin to change. The equatorial radius is about 6,378.1 kilometers, while the polar radius is about 6,356.8 kilometers. The difference is roughly 21.3 kilometers. NOAA identifies rotation as a cause of this equatorial bulge. Without rotation, the planet's long-term equilibrium shape would be more spherical, and rock and water would redistribute. But maps showing 2 neat polar oceans are model-dependent illustrations, not a universal measured outcome. Stopping the spin does not stop Earth's orbit. Rotation is the planet turning around its own axis. Revolution is Earth moving around the Sun. NASA gives the orbital period as 365.25 days and the mean orbital speed as roughly 29.78 kilometers per second. Our fictional braking force removes daily spin, not that much larger motion around the Sun. The year continues. That creates the strangest long-term clock. With no axial rotation relative to the stars, the Sun moves across the sky mainly because Earth completes its orbit. One sunrise to sunrise cycle would take about 1 year. Many locations would experience months of daylight followed by months of darkness, with the details altered by Earth's 23.4-degree axial tilt and latitude. Noon would heat one side for weeks, the long night would cool the other. Oceans and atmosphere would transport some heat between the two hemispheres of light and darkness, so the surface would not instantly split into a furnace and a frozen world. But agriculture, ecosystems, clouds, and rainfall are adapted to a 24-hour cycle. A slowly moving daylight zone would drive persistent weather patterns unlike anything in the modern climate record. The transition, after the initial disaster, would take far longer than a viral animation suggests. One popular claim also needs a correction: the magnetic field would not simply switch off at the moment the surface stopped. NASA and the U.S. Geological Survey trace most of Earth's magnetic field to electrically conducting liquid iron moving in the outer core. Rotation helps organize that geodynamo, but the core has its own fluid motion and enormous inertia. If only the solid surface stopped, the field would initially remain. How it evolved later would depend on what the impossible stopping mechanism did to the deep interior. So the honest answer comes in layers. In the first seconds, inertia dominates, ground stops while air, water, and loose objects keep moving east. Afterward, Coriolis-driven weather collapses into a new circulation, effective weight rises by less than 0.5% at the equator, and the planet slowly relaxes away from its rotational bulge. The orbit survives, turning a day into a year. Earth does not need to stop rotating to reveal how much rotation controls. The numbers already do that.